Hello everyone. This is the actual problem from a textbook. Question number 65. Well, what it wants us to find is the energy stored by the capacitor can be written as 1 half C delta V squared. So at first, what we know is delta V can be written as charge times the capacitance. That is delta V equals to charge divided by C, which is also capacitance. The work done to add a small amount of charge dq when charging the capacitor can be written as dq times delta V, which can be rewritten as dq q over C. Okay. If we move a small amount of charge dq from one location to another, the small amount of electric potential energy change due will be equal to the dq. What I mean by that is, let's say a small amount of charge dq is moved from this position to that position. The small amount of electric potential energy, which is due, will be equal to dq. Well, times the potential difference, delta V. So basically, due will be equal to dq times delta V, which can be written mathematically as due equals to this is a mathematical equation. Well, now if I integrate both sides and set my integral level to 0 to capital Q, I can write the left hand side as UE and my right hand side can be delta V with the relation to the charge and 0 to Q. Okay, and after this, after solving this integral, I can rewrite the same thing as delta V times the capital Q. This is my first part of the equation. Alright. If I try to integrate this equation, I'll label this as equation 2. If I try to integrate this, I can, well, let me put the integration limit 0 to Q, 0 to Q. If I integrate them, I'll get integration of due equals to 1 over C Q square divided by 2, 0 to Q. Now I can rewrite this expression as from equation 1. I can write this as delta V, sorry about that, delta V times Q equals to 1 over 2. Can bring my constant to the front, and I can write this as Q squared, capital Q squared divided by C. Now, if I properly substitute UE as delta VQ, well, I have delta VQ over here, I have delta VQ over here, and in this part of the equation, in equation 1, is equal to UE. So now I can substitute UE as 1 over 2 Q squared divided by C. Okay. Let me have some space. Okay. Now, okay, so my original equation of Q can be written as C delta V. I can call this equation 3, and we can get the form of the energy stored in the capacitor. What I mean by that is the thing that I just integrated from this equation, this thing. I can rewrite this into another form, which will be closer to what we want. So UE is just 1 over 2 Q squared over C, which we just found. Since Q is C times the change in potential, I can rewrite the same expression as 1/2 substitute for Q, that is C delta V squared divided by C. After this, it's just like basic algebra. I can cancel C and one of the C's from here, and I will get delta V squared, which is what we needed, which is what the question wants us to find. So this has been found from all this work, which is this. Thank you.